there, everybody, and thank you for joining us for the webinar today. I'm Andrew Sinclair. I'm the Business Development Manager for Total Water Solutions, and today I'm joined by Michael Dean, who's our Legionella Manager, and Mark Hillsden, who's our Technical Support from our supply partner. We're going to kind of go through a little presentation here about the sort of the next innovation in Legionella, particularly to do with temperature monitoring. But we've just got a couple of house rules to start with. So everybody's on mute at the moment, but what you'll notice on the right hand side of your screen, there's a little sort of drop down bar. If that's not there, there's a little box with a little orange box with a white arrow. If you press that, it'll pop out, and on the bottom of there's a one with questions. If you just type your questions into there, what I'll do is I'll ask those questions of Michael and Mark at the end of the presentation. We find that works quite well. And without further ado, we shall move on. So I'll move on to the next slide. I should point out as well, we're doing this a little bit like a government briefing, so I've got control of the presentation, so you're going to hear a lot of next slide, please. But trust me, there's not a lot of slides, so it shouldn't affect you too much. Okay.
What could go wrong?
What could go wrong? Next slide, please. There we go.
Oh, it's a bit slow, but I think we're getting there. Good. Yeah. Hello, everybody. So yeah, thanks for coming. So just an overview of water hygiene, really. So I think this slide puts it all into context. So if you start at the top, any of you have been to a few of our previous webinars, we've done quite a lot about legal hierarchies and the background and the kind of overview. So basically, UK law, at the very top of it, you've got Health and Safety at Work Act 1974. Section 2, Section 3, which basically says, and if any of you have been to any HSC presentations, it can be quite daunting when they stand in front of everybody and say, those who created the risk must manage it. So I think that's really quite a profound statement, really, because it's true. So basically, if you're looking over buildings and you have responsibility, then you create the risk from Legionella, therefore you've got to manage it. So how do you do that? Well, there are a legal framework in place, Health and Safety at Work Act 1974 at the very, very top, which is the, like I said, the overarching law, and then it filters down into regulations. So that'll be the management of health and safety at work. And then from the regulations, you go down to what we kind of talk about and play with every day, which is the guidance. So from us, it's the L8 and the HSG 274 Part 2. So they're the kind of main documents that we deal with, okay? So so basically, once you've identified the risk, or sorry, once you've associated the risk or worked out there is a risk, you've got to identify it. So how do you do that? Well, you basically start off with a risk assessment. So what we're saying, every workplace must have a risk assessment in place. The control measures don't have to be elaborate, but you do have to have some documentation and kind of a workflow in place. So yeah, so that's the requirement. One of the things that will come out of your risk assessment is there'll be a list of recommendations and control measures. Now, the key control measures, as again will come out loud and clear hopefully in this presentation, the main control measures for domestic water systems, or sorry, for non-domestic water systems, I should say, are temperature and turnover. So how do you know that's working? Well, temperature checks, monthly basis, again more on that later on. And turnover usage. So once you've got those into play, then you're managing and reducing your risk as per the requirements of the law, and you're on your way there. However, I think it's really key to remember that a lot of these control measures are particularly labour intensive. Again, more about that later on in the presentation, but yeah, so that's kind of high level stuff. Another thing to think about as well is from a health risk. It's quite standard, but kind of about 350 people a year contract Legionella disease, and the mortality rate is currently about 9 and 10%. So again, completely unnecessary. Basic control measures, basic processes can eliminate this completely. So yep, that's it. Next slide, please. It's a bit slow with the slides coming down, isn't it? There you go. So yeah, this is my
broadband. Apologies.
Your broadband, is it? Right. Okay. So yeah. So now we started off with a little bit about the guidance. So the guidance we're drawing is for the task list is HSG 274. Fantastic document. A big table in there about what needs to be done by who and when. So this is kind of done graphically here. So you can start off at the bottom. You have weekly tasks. So again, what did we say? Best control measures are temperature and turnover. So one of the weekly tasks can be turnover. So if you've got little used outlets, then every week they should be turned over, as in turn the taps on, give them a good flush. So all you're doing is denying the bacteria the time to grow. So all the bacteria go down the sink in a safe manner. So it's a weekly task. Gone from weekly, increasing the time periods, monthly checks. Now, again, this is what a lot of our staff do when I'm pricing and quoting for monitoring maintenance tasks and programs. Probably about 60 to 70% of the time the technician will spend on site will be doing monthly checks. They're quite a lengthy, drawn-out thing. And again, the guys will pitch up on site with his temperature probe or her temperature probe, take a temperature, manually put it into the electronic database and synchronize it, and that's basically what happens. A little bit more technical because you have to know the guidance as to how long to take the temperature for, what temperatures you're looking at, and where to take them from. So a little bit more technical, but not massively. I still call this a kind of a lower skilled task. On from there, you're on to quarterly tasks. I can never spell quarterly, by the way, but it doesn't matter. Too many R's and T's and U's get confused. But yeah, so quarterly tasks, you're looking at shower cleans, you're looking at TV maintenance and basically tap disinfections. So again, less repetitious, but still done quarterly. From then onwards, you go on to biannual tasks. That's disinfection, sample analysis. Again, a bit more technical now. And then the peak and the pinnacle at the top is your annual risk assessment or risk assessment review. Could be done every 2 years or every year, depending on the risk of the system. But again, highly skilled. So if you look on your left-hand side, we go from the lowest skilled as a pyramid to the highly skilled. Now, having a team of technicians, we do have a lot of guys who are kind of languishing down at the bottom of the weekly and the monthly tasks. It's quite time-consuming. It's not particularly not particularly great amount of job satisfaction, and it takes a lot of time. We spend a lot of time knocking on doors, signing into logbooks, going through RAMs. I'm sorry, Mrs. Miggins can't come today to open the door because she's got a hair appointment. We get a lot of that, and it's basically repetitious, time-consuming, quite inefficient. But there's a lot of that going on between the lower end of the pyramid, and yeah. So again, control measures: keep it warm, keep it cold, keep it moving. Okay, thank you.
Okay, so what we're going to be talking about today is Michael's given a really nice summary there of the way that a contract might be structured or a PPM schedule might be structured to take your temperature checks manually using an engineer going to site, and he's highlighted some of the issues that are associated with that. And the purpose of today really is to talk about one of the newer methods of taking those temperatures, which is remote monitoring. And a customer has summarised this to me as in a really neat way. They said, "Well, why would you take the temperatures manually when you can do it remotely?" So the analogy is, if you're driving along in your car, would you check your speed by driving through a speed camera once a week, or would you look at the speedo continually to see how you're performing and what's happening in your system? So that's the kind of analogy when you're looking at a comparison between using a remote system to take temperature continually and getting a 24-hour readout, or using a manual temperature monitoring. Next slide, please, Andy. So one of the points key points that Michael made just then while he was talking to us was about turnover and temperature. And the reason that you need turnover is to deny bacteria the chance to grow within your water system. Now, when you're taking temperature manually, it's typically done in accordance with the HSG guidance once a month by an engineer coming to site to take those temperatures, and that's indicated here with the blue dots. That might be your engineer visits to come along and take those temperatures. Now, the graph we're looking at here is a hot water cylinder at a hospital that should be reading in at 50 to 60 degrees every week, and actually in this case went offline, as you can see quite nicely indicated by the graphics there, and no one on site reported it. So that water was then sitting there at a really nice temperature for bacteria to grow for quite a long time. Now, we obviously did report this back to the FM on the site, and they were able to do something about it in terms of isolating that system and making sure there were no risk to people in the building. But if you don't have access to that kind of information, then there's a potential that there could be a risk in your system that you're not aware of, and that might take a couple of weeks or 3 weeks or 4 weeks to be highlighted because it's not picked up until your next engineer visit. So obviously remote monitoring gives you access to some much better and more kind of real-time data about what's happening within your system. And Andy, you playing Call of Duty in the background?
Apologies, my wife is working from home today as well, so maybe she's stealing some of my bandwidth. I need better broadband, I'm hoping.
Okay, so how does it work? This is an overview of the system, and so it's an Internet of Things system. So it's comprised of three distinct elements. So first part of it is the actual temperature sensor itself. So the S1 temperature sensor, it's a smart sensor. It has a microprocessor inside the black box, and that lets us code it and program it to do exactly what we need it to. They're retrofitted to the water system. It takes a few minutes to install for the engineer using an app to tell it where it's installed, give it the right trigger temperatures and specify it. As Michael said, there's a little bit of skill involved in making sure they go in the right place and on the right parts of the water system. The surface probes fitted onto the pipe. The unit itself is waterproof and it has a 10-year battery life. Now they take temperature exactly in accordance with the guidance that's outlined in the HSG regulations, and that's really important. That's what the microprocessor in the box allows us to do. It allows us to really selectively take only the most relevant temperature data and transmit it. That helps keep costs down because you don't want to be taking lots of unnecessary data. You just want to be able to carefully select the bits that you do want and transmit and record those. That's the actual temperature sensor itself. So you put those around your water system, and we'll talk a bit more about where they go in a minute. The second part of the system is a gateway. So this has typically got a cellular connection in it, so we don't have to disturb your IT team. That links to, you put one of those on site that's mains powered, and that links to the network of sensors by radio. Now they can be positioned a long way away from the sensors in line of sight range. Outside we've had them 22 kilometers apart, I think they were tested to. When we did the initial tests on these, but we've also tested them in tower blocks, in hospitals, in large awkward buildings and underground. We've had them a mile apart on one site at an airport. We've had them 11 stories apart in concrete buildings. So you get quite a good range, and that helps us to keep the cost of this equipment down. The third part is the web portal. So there's a web portal that's associated that collects the data securely. It's transmitted from the gateway back to the portal. There it's collated, sorted, and any exceptions are drawn out, and then reports are sent from that portal directly on a weekly basis to tell you where risks are and what's happening. And lastly, there's an ability for you to extract data from this system. If, for example, you had your own CAFM system or your own compliance software, and you were recording information on a monthly basis or weekly basis in that, and that generated your task orders on site. Lots of FM companies or larger estates might have their own work order or task order systems. And what we can do with the web portal is send information via API over to that kind of software, and that generates a task order. So for example, your temperatures this week haven't been in spec. You need to do something to increase the turnover on that water. So the exception data is sent across to the CAFM system. That generates a work order for an engineer who then goes and flushes the tap. And that's in a nutshell how the system works.
So yeah, over to me. So basically the question is where do we put these? Where do we put the kit? So I think the key thing is to start off when we look at pricing of this sort of installations. It can vary much. We can basically do exactly what you're doing like for with the man in the van and a temperature probe, or we can go kind of basically put temperature sensors all everywhere. So the minimum requirement is sentinels and heat sources. So if you look at the schematic there, it's a fantastic little drawing. You can see obviously the blue dots where you would put take a temperature from the cold, and the reds the hot. So remember, sentinels from a water hygiene perspective, nearest and furthest. So calorifier, you would take one from the nearest outlet, or you can see at the very top, the best one is a storage system. So you can see the first outlet there from the outlet, and the furthest at the bottom left hand side, that's just the furthest sentinel. So it's a great way of looking at a water system, because you can see the interaction of the building on the water system itself. So for instance, in the summer, when we get one, you might find that the heat from the building will transfer into the pipe, the cold pipe, so that your furthest sentinel you might get 2 or 3 degrees of heat gain. So again, that's a potential area of concern. You might be outside of your threshold from your compliance schedule. So that's something to think about. So yeah, so basically two ways of doing it. You can do exactly what you're doing with the man in advance, so the nearest and the furthest from your sentinels and all your heat sources. Or you can go, as we've seen in hospitals and other complex buildings, every single outlet. The more you put in, the bigger picture, the better picture you're going to put in, because don't forget, if you've got inherent temperatures, it will highlight the fact you've got turnover issues as well, potentially. And then you can start going and doing flushing regimes, which otherwise you wouldn't have known. And I think that the other thing that I'd like to get across for today is, having sat on client meetings every month for a long time, we always have an issue with temperature regimes, in the sense that you go through the failures, what has failed and what hasn't failed. Having seen firsthand, and again, many people will be watching this, when you do get a temperature failure, it creates a hell of a lot of work. Potentially, you've got to go back, you've got to take time of your day to take another temperature. And we all know that potentially it's been in makeup. So in which case, the temperature you've taken that once in every month isn't particularly accurate anyway. All this will do it in the middle of the night, as long as the regulations or the guidelines say it's got to be within temperature for 1 hour in every 24 from your hot. And I was looking at the system this morning, one of the buildings that I'm overseeing, it got to our temperature midnight last night. Happy days. So it's fed in automatically into the database, and it's become a clear result if a man in a van would have failed that. So it's automatically saving work on the first day it was installed, or second day it was installed. So it's fantastic in that respect. So yeah, so there you go. Really, there's a little. Also, you can put it in tanks as well. At the moment, there's a requirement that you go in every year to look at in the summer months, take a temperature and have a look at the internals of the tank. Now we can put basically put the probe into the storage system itself. You can gauge turnover, you can gauge temperature, heat gauge. You can get so much more than it's, like I say, it's done passively. So once it's installed, that's there forevermore. So yeah, so tanks, storage systems, calorifiers, anything over 15 litres ideally. Flow and returns, colds, absolutely fantastic, really useful. So there's a little bit of a comment from Matt Morse at the bottom, really. So basically just agreeing with what I'm saying. So the more you put in, the better information you have regarding your system. So yeah, that's it.
Now this has come onto my slide and it comes up pretty quick on my side, but I don't know if it's come up on yours yet, guys.
Yeah, no, we haven't seen anything yet.
There we go.
There we go. God, my word, I definitely need better broadband. Yeah, so one of the things that when sort of Michael and I started off on this journey, which seems like quite a long time ago, when we knew this was the way that the industry was going, and it was the next sort of logical innovation that would come from this type of activity. One of the things we need to do is to make sure that this wasn't just it makes it easier for us to manage from a contract base. It needs to be a benefit to the customer, otherwise it's pretty useless. So what we've got here is just a very sort of like general list of some of the main benefits that it offers to you as customers. Obviously, you get a reduction in risk, and that's because you're getting these multiple data points across time. You're not having anything where we have incidences where unfortunately people do get ill, and you've got to then try and rearrange to get someone there. If something gets missed, then it's another data point that's missed, whereas this sits in situ in your building all day, just gently in the background taking readings and passing them to you, so you can monitor your systems better. It reduces disruption as well, which I think is probably one of the main things for both ourselves and our customers. So from our point of view, our biggest issue by far on any contract we have is access. And if we kind of look at the awful thing that we've been all going through for the past 18 months around COVID, it's been particularly tricky to be able to continue to do that. But actually there's a further sort of disruption in there that is just sometimes we need to be in tenanted properties, sometimes we need to be in halls of residence, and just the fact that our operatives are in there sort of wandering around can just cause a bit of nuisance for the people that you're responsible for looking after. So the idea that this just is installed once, it sits there in the background and just ticks over nicely, again sort of reduces that disruption. Michael and Mark have both mentioned that there's this idea that you can identify risks that you wouldn't be able to do, or if you were to be able to do it with the traditional technician in a van model, it would probably take 3 to 6 months of readings to think, yeah, that's an issue. Whereas this one, because you've got multiple data points going on continually, as Mark showed on that graph, you can kind of see when something drops off all of a sudden, and you kind of highlighted that issue sort of a lot earlier in the process, which allows you to get ahead of it and potentially solve the problem before it becomes a bigger risk or a bigger issue going forward. Reduce cost. This is another one. So what we always say on this is it is generally more cost effective than the sort of technician in a van model. Not always. If you happen to have a bunch of buildings which are very, very close together and you don't need that many temperatures, then it can sometimes still be a cost effective way to do it with the technician in a van. However, more often than not, this model of remote temperature sensing is more cost effective for you as a customer, but obviously we would discuss that as any part of people who are
if I
interested.
could just chip in briefly,
yeah, of course.
Andrew, just say that the awareness on the background to this technology was done in the kind of the Outer Hebrides, that sort of arrangement, because if you think about sending a technician on a ferry to drive around some rural place, it would absolutely cost hundreds of pounds overnight and to take a few temperatures. So this was all done remotely back in the day when the technology is not as advanced and the costs come down every year, as you're aware. So back in the that was the pinch point. That's where it started it off. But just to echo what Andrew said, we've got some rural kind of councils, local authorities. It does become more cost effective to do it this way, simply by the time you're driving miles and miles per site, and say they're hardly ever, not all these sites when they're rural, they're not always occupied as well, so you've got to wait around for somebody to get in. So it just varies. We've got councils who are very much more town orientated, and it doesn't necessarily work out. But I think reducing costs, great, but remember there's more to it than purely finances, because of the effectiveness, and the data set that you get off the back of it is so much more than one temperature a month. So there's something to think about there. Sorry, over to you.
Absolutely. No. And then also you've got this kind of this automated like compliance log, because it is continually taking those data records for you. So if somebody came and sort of part of an audit and said, well, what was it like on this date, you can kind of scroll back and you can see exactly what was happening in that date. You've got a couple of different ways that we can do that, which Mark mentioned. So it comes with this Elliott log portal, which you can use, which both me and Michael really like, particularly me, because I'm not quite as technical as the rest of the guys on the crew, as you can imagine. So for me, it was quite easy to just look at it and understand exactly what it meant. So from a kind of a slightly more layperson's point of view, for me, it was really easy to understand. You can also have those reports emailed. So if you need that to go into a specific person monthly, or you need that sort of monthly report, which I'm sure we're all very familiar with having to produce, you can have that kind of slightly automated. And again, because you've got that API availability within the software, which effectively just allows one computer system to talk to another, the data can be transported in. So for instance, Michael's team use Zeta Safe as their main sort of asset management program around Legionella. This can feed directly into that. So if we've got customers on, which we will have, customers who are using that Zeta Safe system, we can have it just kind of that data just slotted straight into that program, if that's what you're familiar with. Or you've got the Elliott log portal as well, which is great. And then I think the other thing as well is like there's some kind of non-Legionella tangible benefits, which when you look at it, if you think of the amount of effort and time that's taken by a technician, sort of sorting out that work schedule, getting into a van, driving to a particular location, then going out and sort of taking temperatures, then going to the next one, there's a really, really big save on sort of carbon from our point of view particularly, but I think just from a kind of general working in partnership with people to try and make the world a sort of a slightly greener place, then all of that kind of ties into our sort of corporate social responsibility aspects as well. But then on the other side, for sort of the customers themselves, yourselves, there's a saving in water. So this sits in situ. It's constantly taking readings. So during normal day-to-day usage, we can see, because of the data points, that the turnover's happened. So then you don't need then someone to go around and flush every outlet. and waste that water just to then take a temperature, because it actually gets captured during normal use as well. So it's like there's a bit of a saving on water there. And then obviously if we're talking about the hot water side of the system, then there's a definite saving on energy as well, from the heating of that water, which you're effectively wasting by putting down the tap just to take the temperature. We've also got quite a nifty little spreadsheet there, which, you know, obviously we can take that forward if it was something that people are looking to do for their organization, where we can calculate all that for you as well. So you've got a nice little report that you can kind of you can pass on to the organization you work for, to say this is what the potential savings are with this type of innovation. And I think that takes me to the probably the questions section. Now what we've got is we've got a question and answers box on the side. Nobody's asked a question yet, but if you've got a question, please do ask it in there, because we want to be able to answer your questions for you. But what we do have is we've got some frequently asked questions. So we've kind of been out in the marketplace, sort of soft testing this and asking our customers for bits of information and questions around the system. And these are just some of the regular questions that we get asked, which we thought we would ask them anyway to Mark and Michael, just to get their sort of responses. So the first question that we always get asked is it compliant with the health and safety guidance?
Over to you, Mark. Yeah, yes is the honest answer. You can see Matt Morse's comments from the Legionella Control Association. So yeah, it is absolutely fine. As well, just people, so they're calibrated to within plus or minus a couple of degrees, which to be honest isn't far off the standard temperature probes. I was at an install yesterday watching the chaps do that, and yeah, it's a nice little way. And basically the idea is that the probes are foil wrapped around the pipe. There's an algorithm that depends on what the pipe is. If it's copper or plastic, it's kind of it works out what the right temperature is. So in that respect, yeah. And what I like about it is the battery life is 10 years. We've looked at other products, and we're having to factor in going every 6 months to check a temperature. To change a battery every 6 months. So these are 10 years. So absolutely fantastic. So yeah.
Brilliant. I suppose that takes it on when you were saying it's sort of it's calibrated within 1 to 2 degrees. So yeah. Does it need calibrating continuously throughout, Mark?
No, not at all. It's we've actually built into the system. We've mapped the performance of what each sensor should be, and we know the drift exactly over the 10-year battery life. And there's automatic alerts built into the system, so that we get notified if any of the sensors come out of that calibration and spec, and it's checked. There's some self-checking goes on every week on a weekly basis between the sensor and the gateway that it's attached to, and they all just check each other, some cross checks to make sure everything's in line. So we know straight away if for example the sensor's broken or damaged or come out of calibration, we get an alarm. If it's offline for longer than 3 to 6 hours, we get an alarm. So like a theft alarm comes up. We could tell you if the gateway's been unplugged or
cleaners.
If the cleaners have come around, yeah, and it's never any cleaning equipment. It's always their mobile phone charger that's where it should be. We strongly recommend the use of a few spurs without switches when you get to that point as a longer term solution. But that's another story. Yeah, so we know when it's been unplugged, or even we can tell you if it's still connected but the plug's just been switched off. And the gateway has a backup battery of, I think it's about 6 hours it works for. So it gives us enough time to know about the problem, either let someone on the site know to go and plug it back in or turn it back on, or for one of the engineers to go and sort it out.
And what sort of warranty do we provide? That's normally the other thing we get asked, because obviously these are kind of longer term contract sort of discussions. Yep. More often than not. Yeah,
so well, I guess most of these we take out on a lease basis, don't we, Michael? So it's a contract lifetime warranty, so it's fully repairing and maintaining.
Yeah, so any issues we've had in the past, yeah, the equipment's replaced within a couple of days. It's just changed, just done. So
yeah, brilliant.
It's in interest, really. So it's in our interest. We because we offer all our equipment on that kind of basis, fully repairing and maintaining, it's in our interest to make sure it's really good quality. So I think our investment as a business in IoT technology was somewhere around the £3 million mark. We get them manufactured externally by a proper electronics factory, although all the design and code writing and customization and everything is done in-house. Yeah, the actual manufacture is done by a very well recognised name in the electronics manufacturing world. So we're sure that we get good quality kit that we can offer out on a 10-year life and contract lifetime warranty.
And then I suppose one of the big questions that we always get asked is, like, is it secure with it being a new technology?
Yeah, so there's two main ways. So our business is ISO 27001 accredited, and we follow all those procedures. Everything is encrypted within the system. We use Amazon Web Servers to host the data. The data there obviously secure. And the other thing that we do to try and make sure it doesn't create a point of access into the customer system is we use a separate data SIM card or cellular SIM card. So we're not linked to the customer's Wi-Fi, typically not in most circumstances, because that in itself can potentially cause issues and needs fully investigating before we go down those lines. So we keep it as a separate, distinct system. It's not normally carrying any sensitive information, just temperature data anyway. Yeah, there you go.
Brilliant. I suppose the other questions that we normally get asked are kind of around that kind of is it sort of is there an environmental saving, which I mentioned around the sort of the benefits for customers, which we know there is, and as I said before, we can calculate all of that as part of sort of a feasibility study into whether this would work for the organizations who are interested in it. And then also the fact that it does have that integration. So if you're running a separate system and you want to use that as your main way of managing your compliance, then that's absolutely fine. We can just port the data into there for you.
Yeah.
That's
right.
Sorry, Mike, go on.
I was going to say, yeah, that integration piece is really key, because the point of the whole point of the sensors is that they help and support your management and your Legion schema control. There's no point putting sensors on just for data. It's supposed to make life easier for the person managing it. And I've come across some horror stories in the last few years of people going down the IT route without fully kind of investigating it, buying systems that don't have a warranty, aren't managed, that have all kinds of alarming mechanisms in them. So if the temperature gets out of spec, then someone on site gets a phone call, and that might happen on a weekly basis a few times. So you don't want to be upsetting your building managers like that. So I think the important thing is that the customers work with you guys and make sure that it fits and integrates nicely into the way they're doing that, managing that schema control.
The other thing I'd like to add as well is we're talking about automation and reducing technician interaction. Just to reassure people as well is that we will have technicians going back to site, because don't forget there are still tasks that need to be done, potentially descaling. You're not going to get a sensor to descale a shower head. It's never going to happen. So we will be getting technicians on site. So people do like that, because if there's safeguarding issues, or we've had leakage issues, anything like that that's not quite right, it's nice to have boots on the ground to report that. So you will still get that to some extent. So that still will occur. It's just not a case of not having technicians anymore. That's not the case. But as I said in one of the first slides, is it will be doing more skilled tasks less often. So you will get technicians still on your sites, if that's the thing.
Yeah. That's the thing, isn't it? Because this is an integration, isn't it, of a technology into the way of doing things. So yeah, sorry, Mark, you were about to say something.
I was just going to say, yeah, it lets your technicians actually spend time with the customer, helping to fix problems. So they're not wasting time monitoring sites that are compliant. That time can be spent working with the customer where they've got issues, helping overcome problems, adjusting heaters, making sure temperatures are correct, and use that real-time data to improve performance over time. So typically, when you install the sensors, you get a really good view of what's happening with the water system, and there might be some problems that you've uncovered at that point, but within a couple
not washing hands.
Yeah, I think we're going to get some flow sensors out there and get some real data on that. It's seconds, isn't it? It's seconds. So, it's certainly not happy birthday twice. Yeah, you can take that information, can't you? And over the course of the first few weeks of having it on there, you've highlighted all your hotspots where you've got problems. You've overcome most of those, I think, given adjusted heater settings, done what you need to, and then you've left with the problem areas that either need engineering solutions or some kind of ongoing added into a schema control, change of flushing or something like that. So the idea of it is just gives you better data to help improve your performance and compliance.
I suppose one of the other questions that we get asked is sort of, you know, I mentioned before that actually this is a kind of a smart system where it'll capture data as it's being used. So how does that actually happen, Mark? How does it know that the tap's being used, if it's or the asset's being used?
Yeah, good question, because actually that sets these sensors apart from quite a lot. You can buy a temperature sensor off online for pence really, but they're what you call a dumb sensor, so they're programmed just to take temperature every now and again, which is great, but you just end up with lots of information that isn't necessarily that relevant for you. So we kind of reverse engineered it. So we put the microprocessor into the actual sensor itself with these. Sorry, I haven't actually got one to hand, but yeah, inside the box, the sensing unit, that's programmed with an algorithm that's coded exactly to take temperature as per the HSG regulation. So what it does is it takes background temperatures on a 3-hourly for every 3 hours, so you get that 24-hour profile of what's happening in the system. So as Michael said, that's important because overnight some hot water might get back up to the right temperature when you'll miss that if you go during the day to test it. And within the 3-hour window, what it also does is it listens for usage. So it will listen for, it's constantly listening. If it detects a temperature change of 2 degrees, it'll activate, and then it will listen for 1 minute on a hot or 2 minutes on a cold, and at the end of that time period, it will take a temperature. And that gives you, if it's a compliant temperature, then that gives you confidence that that temperature has been taken exactly in accordance with the HSG regs or guidance, sorry, and that temperature is a compliant temperature, and you can put that to one side, and then it only transmits those temperatures that are needed. So that saves you data, saves you cost, and saves the battery. So that's smart. The smart sensor element of it is really what lets us make these competitive and helps give the customer only the most relevant points of data. You don't just want thousands and thousands of temperature points. You want to make sure you're capturing those uses. When the hot water's turned on, it's got to 50. You need to know about that. You don't need to know the temperature a minute before and a minute after and a minute after that. You just need to know the exact points when it's been used.
Brilliant. Well, that takes us to the end of our questions. I'm just wondering, Mark, do you want to load up the Elliott log portal? And what I'll do is I'll hand you over the presenting screen.
Here we go then. Right, let me know when you can see this.
Yep, that's it. That's quicker than mine.
So this is an example site. So this is our head office. And what you see when you log in is a number of tabs. So you have the locations where the sensors are installed, which gives you the granular data, what's exactly happening with the sensors at any one time. So we'll log into the kitchen, and we can see what the guys are up to in our office today. So, well, we can see that this date for the temperature, the sensor that's fitted to our kitchen hot is set to on a threshold temperature of 50 degrees. It's a hot water sentinel. We can see when it was installed and what kind of pipe it's installed on. We can see the battery and the signal and the last temperatures that were taken. We can even add a manual reading in if we wish to. So what this shows us is the temperature data over the date range. So we can see that actually this outlet for a period at the start of April wasn't used very often. Perhaps that was a time when the office was closed. But actually what's happening now is that we're getting lots of nice spikes in usage, which shows that that system is being used, it's getting to a compliant temperature, and there's not really much to worry about there. Now, same thing for our kitchen cold. It looks like it's fairly frequently used, and we can see lots and lots of temperature data and lots of nice ticks for the period. Now, I'm not sure what the information is like in the other. Our office is a bit of an Aladdin's cave for electronics, and we tend to have all sorts going on there. So I don't think I've got any non-compliant outlets to show you on that.
But I think it is quite powerful, Mark. It does show exactly how it works. You can see what I like is obviously the cold is an inverse for the hot. So when it's not being used, the temperature will rise, and as soon as that tap's open, you can see the cold temperature dropping, and likewise for the hot, you can see it peaking. Like you can see it's being used. Fantastic stuff.
Yeah,
really powerful.
So within the
So I suppose for this as well, it's kind of from a customer's point of view, what they'll be able to see is they'll be able to see their sort of company name, click on it, and then it'll break it down into sites, which then breaks it down into assets. So it's nicely uniformly structured so that people can get to exactly where they need to get to.
And the other thing as well, which I really like, on a weekly basis, you do get a report. So if it's just a matter of, it comes automatically as a PDF generated, so you can see, download everything there. So from a compliance, when people report it back to the management teams, it's there straight away. They don't have to do anything. It's just passive. It comes to you. It's fantastic.
Yeah, that's it. And actually, what the report will give you on a weekly basis is a bit of an exception list. So which of your outlets needed flushing during that time. So we always forget about the cleaners cupboard, even though we should know better. So that definitely needs doing. It gives you a bit of information about how many passed versus failed temperatures were taken during that period. And that's actually quite important, because that gives you a bit of a ratio of how long the system may have spent in a compliant versus non-compliant temperature range. So you can use this to do a bit of digging in and see what's happening. And then for any non-compliant assets, it will give you a graphic to show you exactly what's happened with those. So you can see effectively this is just little used. Now that report is emailed out on a weekly basis to a site responsible person that we can allocate in here, and then that goes off to that lets that person take control on site, and we can put anyone in there or do anything we need to. But we can also do reports on a monthly, or summary reports on a monthly or quarterly or annual basis for people at a higher level who are looking at a portfolio of multiple sites. That's it.
Very good. Thanks, Mark.
Brilliant. Thank you very much. Well, that takes us to the end of our presentation webinar. We hope that you've enjoyed it, and that you kind of it's maybe piqued a bit of interest on how things can maybe move forward and become that little bit more innovative for your organisation. If you've got any further questions, you can get us. You probably know most of us already, but if not, you can get us at the TWS email address, which is tws@nwl.co.uk. And if you want a sort of a further demonstration of the software, or you've got a few more questions that you'd like to ask, please just get in contact with us. Other than that, the webinar is being recorded, so we'll get that up on the website. So if you want to have another look at it, because it was just so good, or you want to maybe pass that on to somebody else in your organisation to have a look at, please do so. So other than that, we'll say thank you very much and goodbye.
Thank you very much, everybody. Thank you. Goodbye.